Hello, I just bit my cheek. Oh, it was terrible. It was awful. All right, who we got? We have Elena, Jessica, Sydney, Alyssa, Vestal, McKenna. All right, so I started getting through some of your flip grids. I didn't get through all of them yet, though. They take a long time to grade, but they're so fun to watch. I'm sure they're fun to make too, right? All right, I have a weird poll question for you. If you could have taken this class at any time of the day, what would have been the best time of the day? Or is this the best time of the day? Like, is right now good? Or you can put like a time of the day. Please don't put 2 a.m., like something that would be more possible. So, and just type it in the chat. I'm just curious. Because this class has been offered at noon for 20 years now, I think. Yeah, and if this is perfect, let me know that too. Nobody wants to take it at night. Nobody wants to take it at 4 o'clock in the afternoon. So 9 or 10 or now is what I'm hearing right now, right? Nice. The only reason I asked is because we've talked about changing the time of this class, but we never want to overlap with the education classes that are offered too, right? Because sometimes education classes are only offered because there's so few of them, and mine too, that we don't want them to conflict. I used to teach this class at night before I taught full time at the community college. So I used to teach it 2 nights a week, which was fun. Like for students who have to work full time.
What time would you teach at night?
I used to. I don't anymore.
Oh.
It used to be at 7:10 at night. It was like 7:10 to, I don't know, some stupid time, 8 something, 8:30, 8:50. We don't offer it at night anymore. So we did, and it was very popular, but they needed me to teach in the day, and the person I used to teach at night is no longer technically certified to teach this class according to our HLC criteria. So yeah, weird. Okay, good to know. So Questions about rock, paper, scissors, since we finished really quickly and ran away, right? You did do your exit ticket and everybody got it right. Because basically we're talking about the difference between, we're going to revisit rock, paper, scissors about experimental versus theoretical probability. So first, questions anybody has? Let's start over. If we share Wednesday, how about we share on Wednesday?
I do have a question on that homework though.
Good, I'm ready, Jessica. And then
yeah, I'm just
share
trying to
whenever.
get to it because it's a specific one. So question B, I was kind of stuck on.
Question B. Where are we at? Right here?
Yeah, yeah.
Oh,
So
I'm gonna
like
make you
I
think about that.
understand how to get the probability of each one. It's just the probability of both I'm stuck on.
What do you guys think? So if you go back here on your table, right? If we go back here to our tree diagram, this is SR right here. And this is RS right here. And so think about, we went along this branch to get here. We went along this branch to get here. So there are two different outcomes. What did we do with different outcomes? Think about our pom-pom activity that we did. You guys can help Jessica out. It's not just Jessica can figure it out.
You would add them together, right? You would add the outcome of SR with RS.
How many of you agree that you would add those two outcomes together? Yeah, because we know that all of these outcomes must sum to what? One. Sorry, McKenna. I saw it and it took me a minute. Yeah. So Jessica, does that help you?
Yeah. Thank you.
Okay. Excellent. Okay. So first, before we go back, we're going to go to, which part did I want to go to? Oh, we were going to, it wasn't this packet that I wanted to revisit. It was the coin one I wanted to revisit. This one right here. Remember this? Remember this nonsense we had going on the other day? Yeah. Okay. So before we revisit, now, Maddie, you just made me want chapstick. Tyler and McKenna are making me hungry. This is a hard class to be a part of right now. Let me tell you, it's okay. You're fine. Keep eating, no worries. But Tyler, I need to know what that is and where it's from. Did you make it? It looks amazing.
No, I just stopped by Chipotle real quick because I've been up since 3 o'clock at work, so I'm starving.
I knew it was Chipotle. So, but the last time I had Chipotle, it was not good. And that was depressing.
I don't know. I know the manager of this restaurant, so that's why I swing by real quick and he has it ready for me and I dip.
That's perfect. Does he run it out to your car or do you have to go in?
Not yet, but I'm getting to that point soon.
Yeah, I'm pretty sure Chipotle should have a drive-through because that's irritating. Yeah, thank you, Jessica. Yeah, it's true. Okay, so good, Tyler. And McKenna, are you eating anything good?
I'm just eating oatmeal.
Oh, plain, or do you have anything in it?
It's like a protein oatmeal, so it has PB Fit in it, which is really good, and then some fruit.
I do like PB Fit. It is good. I put it in pancakes. It's really good in pancakes and smoothie, and apparently oatmeal. Okay, and Madison, was that good chapstick?
Oh yeah, it's the limited edition candy cane chapstick. It's the only one that I'll use.
Oh my gosh, how do you have, did you buy cases of it so you don't run out?
Oh yeah, in December. It comes out in November, December, and then I just buy the whole carton. So I have them throughout the year. Yeah, it's an addiction. It's bad.
That is hilarious. I thought it was going to be Burt's Bees. So no, Burt's Bees is too expensive in my book. That's where I am with that. So yeah. Okay, good. So sorry for the side note. A lot of you are eating right now because it's lunchtime and it always looks so good. So thank you for sharing. Now you make me want Chipotle. And not oatmeal. I don't want oatmeal right now. Sorry, it's too warm from oatmeal for me right now. But now I do want some peppermint chapstick, not to eat, just in case you thought I was eating it. I'm not. Okay. So, by the way, I just implemented a new review in a different class, but I just want to tell you, since you're all future teachers and you guys are making flip grids, or you did make flip grids, and I'm about halfway through them, just in case you're wondering. I haven't gotten through all of them, but I will. And the reason I bring this up is because think about this idea, because our kids are very tech savvy now, right? Especially after being online. They've been using a lot of different apps that they're not used to, but now they will be used to it when you get back in the classroom. And so when you're in your student teaching, and your internships and things like that that you're doing, your observations, you're going to see what kids have available to them. And what's nice about this, so listen to this review I have. So for my class, I have like a practice test, right? So, and I usually give them the key before the test. So they do the practice test, then I give them the key, and they can ask me questions about it. Well, what do you think they do? They don't really do the practice test, right? They just look at my key, and then they go, oh yeah, we don't know how to do any of these. Can you explain them all? And it defeats the purpose, because if I explain them, then I'm doing the math instead of them doing the math, right? So my new strategy for them, for this class in particular, so I have, lots of problems on the test, or on the practice test. There's like part A, part B, part C, part D. So this week I assigned a different student each part of each question, and they have to make a video explanation of it. And so they have to have a written explanation, like with a whiteboard like this, you like how it says, this is my solution. I don't know if you can read that. That's what it says. This is my solution. And then they'd have to explain the problem. And then they're doing it on a discussion board. I didn't use a Flipgrid because they've never used Flipgrid, and I was figured they would have a heart attack with Flipgrid. So I just made it, in discussion boards, you can upload media too, right? So they're going to do that. And then they have to respond to 2 other people. So hopefully they will catch their mistakes if they do it wrong. And they could take the question to the tutoring center if they want, right, to get help on it beforehand, or they could meet with me. But just having to explain it is a very meaningful thing for them to do. So think about that when you get back in your classroom. Your students probably have access to iPads, laptops, things like that, whether at home or at school. And you could have them review for a test by making videos that explain a concept to each other. So that would be really an awesome thing to do. Now, you won't be having them explain probability, because they won't learn probability until 7th or 8th grade. But we're going to head to statistics next week. And statistics, they definitely have to learn some of those, especially by 6th grade. And we'll talk about what the standards look like in 6th grade. And then part of statistics is all data displays or types of graphs, like a bar graph, a line graph, a pictograph, a circle graph, a histogram, all of those things. And they have to learn those starting as young as kindergarten up through. So they could make videos. They can make videos when they're pretty young, and it's a great way for them to explain things. I hope we do more flip grids in here, because I've had my students start explaining things, and I think it's real helpful for you to see each other teach things, right, and explain things. So keep that in mind when you're doing it with your own classes, okay? Okay. Okay. Now, we'll revisit well, why don't we just finish the rock, paper, scissors? Does anybody else have any other questions about rock, paper, scissors? I don't want you to be finishing the packet right now, but any other questions that I can clarify for you? All right, we're good on that. Let's revisit this. Did we compute we did do our percentages on this. Now we were just talking about the expected probabilities, because we have our experimental data that we got, which was, what did we say we had? So for no heads, we had 26.2%. And then for one head, we had 47.6%. And then two heads, we had 26.2%. And if we were going to investigate the expected probabilities, what are the possible outcomes when we flip two coins at the same time? What are our outcomes there? It's not a trick question.
We can have heads, tails, tails, heads, or tails, tails.
Heads, tails, and tails, tails. So there's 4 possible outcomes, right? Everybody agree? Okay. Now, I want you to think of the percentages for the probabilities you would expect on each one of these. Anyone know what you would get for each one of those? For 0 heads, 1 head, and 2 heads? Hannah's the only one in our class that wants to answer. Do I have to get out my wheel and spin? I don't think we want to do that, do we?
I can try.
What do you think, Madison?
Well, I see that there's 3 of those, and you know that a percentage is out of 100, so I just divided it kind of by 3 and estimated that we would expect there to be like around 33%. I mean, each group to have 33%, you know.
I follow your strategy. I'm just wondering about its accuracy. Jessica, can you explain what you put in the chat? Jessica said 1 head is 50%, 2 heads is 25%. Where'd that come from?
So for the 1 heads, you can tell to see that there's 2 of the 4 outcomes. So I did 2 over 4, which gave me 0.5, so times 150%. And then same thing with the 2 heads. There's only 1 out of 4 times that can happen. So I did 1 over 4, which gave me 0.25, which times 100 is 25%.
So do you see that when we look at these outcomes, tails, heads, and heads, tails both fit the criteria of 1 head? Yeah, so that's why it's 2 out of 4. Normally, Madison, I would agree with you. If there was only 3 outcomes, you would divide it by 3, kind of like in our rock, paper, scissors. But in this one, you might even think of a tree diagram, right? I know you're like, if she brings up another tree diagram, I'm going to have a heart attack. Okay, so think about this. Here's your tree diagram, heads, tails, heads, tails, heads, tails. So these are all 1/2. Why is the probability of heads or tails always 1/2 when I flip a coin?
You only have 1 outcome and there's
Yeah, we only have 2 possible outcomes and we're only getting 1 of them. So that's 1 out of 2, also because they're independent events. Remember that? Okay, so, and if you notice here, if I follow along a branch, 1/2 times 1/2 is going to be 1/4, 1/4, 1/4, 1/4. And so those right there are 1/4 and 1/4. That's what Jessica was talking about, 2/4. Okay. And Hannah said this idea is explained nicely in the probability video assignment that's due today. Is it due today? Oh yeah, it's Wednesday, isn't it?
Yeah.
I thought it was Thursday for a second. Is it the banana video assignment or is it the other one?
No, it's the other one.
It's the other one, which I can't remember the name of it. But I love that last banana video assignment. I don't know why. I just think it's really cute. Okay. All right. So compare these with our experimental percentages on the previous page. Notice we were close to 25% and we were close to 50% in our experimental probability, right? So, and if we repeated this experiment again, we would get closer and closer and closer to that probability of 1/2 and then 1/4 for the other two. So remember, this right here, what we're doing right here is theoretical probability. What we did up here was experimental probability, right? Okay, do you see this extension at the bottom of the page where it says, using the previous two examples, design a similar activity, but for flipping 3 coins at the same time? Write out the directions in the solution below. That's a great extension activity. I'm not requiring you to do it, but I will tell you that 3 coins is something that's usually on the midterm. Yes? Probability with 3 coins. Okay, so might not be a bad idea if you're studying to draw a tree diagram for 3 coins and calculate all those outcomes, just so you have done it once before you get to the midterm. Yeah? Okay, so you could write yourself a little note like this on midterm. Consider drawing tree diagram. Nice. All right. So back to today. A lot of you have heard of odds before, right? But you might think they're the same as probability, and they're not. They're related to, but we have to be really careful. And this is one of the biggest mistakes I see kids make, as well as you students in my class. You have to look and see if the question is asking for odds or if the question is asking for probability, because those mean different things. Okay, so like on your more homework, be careful, right? On your midterm questions, be careful. So before we get into that, let's make sure we all understand probability. Draw a tree diagram for drawing 2 slips one at a time from a bag containing slips of paper with the letters M, A, D on them. This is without replacement. Label all probabilities and all possible outcomes. So we're only drawing 2 slips, right, of paper. So you just have to do first draw, second draw, and we're doing them one at a time. Look very carefully, without replacement. So try that. I'll give you lots of minutes to think about that. And everybody should draw it. Is anyone done already? A couple of you are done. How many of you need more time? Okay, just a little more time, I saw. All right, did you finish? Yay, okay. So if you did it on paper, can you hold up your paper so I can see it? Everybody hold up their paper. Very nice. Once I say your name, you can put it down. Jessica, you can put it down. Karina, Kelsey, Tyler, Elena, Madison. Brianna, do you have numbers written by those two? Do you have the probabilities written there?
No, I need help on that.
Okay. Bethel, did you write it? Good job, Hannah.
I only got to this part. The probability and the numbers, I was having trouble with it too.
Okay. Those of you that I don't see, like McKenna's showed me hers. Good job, McKenna. So Andrea, did you finish? Alyssa, hold it closer to your camera for me. Okay.
I didn't do much because the tree thing kind of confuses me.
Okay. Betty, Michaela, Sydney, Vanessa, I can't see yours. Did you get it?
I'm having trouble with mine.
Okay. So you have to be real careful because this class is not a passive class, right? So when I say draw, this is not just to you, Betty, by the way. This is to, there's probably at least 10 of you that either didn't know what to do and just sat there. Nobody typed anything to me in the chat except for Hannah asked me a clarifying question. So my assumption is you know what you're doing. Okay, so you have to be real careful. When I was watching your videos, I know a lot of you said that you wanted your superpower to be reading minds, right? And why did you want your superpower to be reading minds? Because your students don't tell you when they don't understand. Guess who you are right now? You are those students. Yeah, you are those students that are not asking questions to help yourself. And if you're worried how you're going to look to other students in the class, that is not your worry. Who cares? Are they getting your degree? No, you are getting your degree, right? You are the one who needs to learn it. You are the one who needs to understand. So think about how you want your students to behave in your classroom. That's how you need to behave as a student. When you don't understand, ask a clarifying question. Like Jessica did at the very beginning about that probability. right, on those trees, it was very helpful for Jessica, right? Now Jessica, I think, is confident and now she can finish that assignment accurately, right? So that's what you need to remember is I'm not here to judge you. Neither are your classmates. You watch their videos, right? Everybody in our videos were like, we're all the same type of person. We all want everyone to understand and to help each other. So if you don't know how to do it, it's a perfect time to ask a question. And it might be something really easy, right? So those of you that are really struggling with the tree diagrams, did you go to that website and try it? Remember the one that I gave you extra credit for?
Yeah.
I had 3 people turn it in, I think. And if it was hard for you, come visit me in my office hours, right? I have it tonight, or send me a message that says, you know, I just can't come to your office hours, but this is what I'm really struggling with. Is there any way you can direct me to a video that would help me, or make a video for me that would help me, right? Because that's why I'm here. But if you don't ask the question, I don't know you don't understand, because, by the way, I don't have that superpower. Just in case you thought I did, I don't read your mind. I wish I could, but I can't. So let's just start, because even though some of you didn't know how to finish your tree diagram, you definitely knew how to start, right? So the first thing I do is I label, this is my first pick, right? So in my first pick, and I only have 2 picks, first pick, second pick, right? How many choices do I have for my first strip of paper? Everybody hold it. There you go. 3. Everybody says 3. We all agree, right? Even those of you that are super confused on how to do it. And our 3 outcomes are M, A, or D. Everybody with me so far? Questions on that? Okay, now, Hannah's question that she clarified was, how many, actually, I'll read it because it was worded very nicely for me to see where the confusion was. Hannah's question was, hold on. Are there an equal number of each lettered strip? That's a great question, right? Are there an equal number of each lettered strip? Well, when you read it, how many strips do you think are in the bag? Yeah, there's only 3. And that's what my response to Hannah was. It said, yes, there are only 3 strips in the bag, 1 of each, M, A, and D. So that clarifying question of Hannah's showed me she was thinking about the problem. She just needed to make sure she wasn't thinking of it incorrectly. So don't feel bad asking those questions. Now, if you know there's only 3 strips and they each occur only once in there, and you're going to pull one out, what's the probability you get an M?
On the first pick, 1/3.
1/3. And that's true for each letter. Do you agree?
Yeah.
Everybody agree, because they're all the same in the bag, right? Okay. So now on my second pick, this seems a little far away. So on my second pick, let's think about this. You might go, okay, now on this branch, I already picked an M. So are there any more M's in the bag? There's no more M's in the bag. So there's only a choice of A or D. Now, did anyone put an M here? It's okay if you did. Jessica did, Bethel did. It's okay if you did. It's totally fine if you did. You just have to be careful and know that once you do it here, you're going to go, oh, well, there's no chance of getting that, right? So then that probability will be 0. So I didn't write it, right? But I'll just put that dotted line in there in case you wrote it. If you wrote it and you put a probability of 0, you're not going to lose any points, right? You're fine, right? Because you understood what was happening. Does that make sense to everyone? Does everybody see why M is really not an option on this branch because I already took the M out?
So
Okay,
technically,
good.
so a question. So technically, we don't use the M because that's what we started with in the beginning. So it
Only
would
on that branch, right?
Yeah, on that branch because we used it in the M, on that first branch.
Nice.
Okay.
Yep, Vanessa, perfect. So now on this next one, am I gonna have 3 options after my A? I'm only gonna have 2 options. What are they?
M and D.
Very nice. Again, if you did 3, just know that one of those branches is 0, right? Because there's none of those in the bag. So it's okay if you drew 3, as long as you know that the one that you already picked is 0. And then here, there'd be 2 of them, just A and M. Is everybody okay with that? Before we write in any more numbers, I need to make sure. Any questions on what just happened? Those of you that struggled a little more, I want to make sure you have a couple seconds to think about that or ask me questions. Okay, now what probability would I put on any of these lines? Here, 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 here.
Would it be 1/2?
Here, and here. Yeah, it would be 1/2. Why is it 1/2?
Because there's only 2 possibilities.
There you go. There's only 2 choices because one of those slips of paper went away. And that's because it said without replacement. If it said with replacement, I would have 3 choices at all of these, right? Because my sample space doesn't change from my first draw to my second draw if it says with replacement. Yeah. Okay, so then all our possible outcomes are MA, MD, AM, AD, DA, and DM. And each one of these would be 1/3 times 1/2, which would be 1/6, right? And if I sum all of those, I would get 6/6 or 1/2. Yeah? Everybody okay?
One quick question for the, I don't think it's AA, I think it's DA because we can't get A twice,
Oh.
right?
Thank you. I just had a little writing problem. DA. Thank you, Madison. Oh, good. And Sunita told me too in the chat. I just didn't read it.
So I did draw mine. What I was trying to say earlier, I just realized that where I would have caught my mistake is I drew 3. I don't know if you kind of see it. Like that's the first one that I did wrong. I don't know if you can kind of see it, but when I did the second part, adding 3, it still wouldn't make sense now that I caught my error because I did 1/2 for each of them. So if I added it up, it wouldn't have been a whole. It would have been 3/2.
Nice, nice. Good catch. And it's good to keep your wrong work, you know, and then make a note of what mistake you made, because if you made it once, you're likely to make it again, right? So those of you that tried that extra credit tree diagram part, do you think it helped? And I think it was like Sunita, who else was it? Hannah, there was one other person.
I turned it in.
Okay.
But it was still kind of confusing.
What was confusing about it?
Well, just distinguishing when it was when you had to take away when it said without. I think it was like the baseball one or one of them. It was like taking it down how the fraction changed versus when you don't take it out when you replace it without replacing it. That was confusing for me.
Yeah. Good. Okay. Is everybody okay with this now? Did this help you? Specifically, Kelsey, Brianna, Alyssa, Michaela, Sydney. I have to ask the people I can't see just to make sure. Kelsey, yes, I can see you, but in case you thought I couldn't. Okay, good. So I don't mind going over things if it's helpful, right? But I'm just going to assume you know what you're doing otherwise and move on. So make sure you ask those. Okay. So odds. Odds is a ratio of the number of ways something can occur to the number of ways it cannot occur. That's different than probability, because probability is the number of ways it can occur to the total number of outcomes. Do you see the difference? Odds in favor is how it can occur compared to how it cannot occur. And I really, really like these words. I remember these very, very well. So for odds in favor, I think of success to failure. For odds against, just reverse that, failures to successes. Okay? So if I have an example, this example is kind of stupid. I think it was in a book. The odds of a month being August, the odds in favor of it being August are 1 to 11, because there's only 1 month that's August, and there's 11 that are not August. Do you notice how that's different than probability? If I say, what's the probability that you choose a month that's August, that would be 1 out of 12 instead of the odds in favor of 1 to 11. Do you notice that? Okay, and then not being August, so odds against would be 11 to 1. This is a real easy one for you to remember, this last one right here. The odds in favor of a coin being heads is 1 to 1. Remember that probability is 1 out of 2, right? So do you agree in this, the total must be equal to successes plus failures? Does that make sense to you? So if you notice, 1 plus 11 is 12. That's how many months there are. 1 plus 1 is 2. That's how many sides of the coin there are, right? 2. Does that make sense? Okay, so just really look out for those words odds. This is just an explanation of what odds is, and I give you an example out of rolling a dice. And it's just really important for us to remember, is it probability or is it odds? Okay, again, here's another example, odds in favor, odds against. I don't know why those are repeated, that's weird. Okay, so let's connect odds and probability, okay? So if I tell you, it's only using the numerators of the complements of an event. Yep, absolutely. So it uses the numerators. Very nice. Okay, so if we look at this one, wow, I don't know why that just turned around. Did it just make you sick? Sorry about that. Okay. If I know the probability of an event occurring is 3 to 10, it says find the probability of the event not happening. That sounds like a complement, right? A complementary event. So how do I find the complementary event? How do I find the probability? We're still talking probability first, then we're going to talk about odds. So number 1 is probability.
Don't we subtract like a full like 10 out of 10 and subtract the probability of it happening?
Nice. Absolutely. That's exactly what we do. So if I want to find the probability of the event not happening, that notation should look familiar, right? The probability of the event not happening, it would be 1 minus the probability of the event happening, which would be 1 minus 3 over 10, which is 10 over 10 minus 3 over 10, or 7 over 10. So very nice. And you should be able to write and understand all of those things that I just wrote down. Any questions on that? Do you see how this takes practice to write it all down? Okay. So now we have to think a little bit. When we're saying odds in favor, what's the formula for odds in favor?
Successes and failures.
Very nice. Successes to failures. And sometimes it's more common that we write it with a colon in between instead of a fraction, even though it can be written in fraction form, just so you know. But to help you understand the difference, you might want to start writing it with a colon in between. So what are the successes of this event happening? What number would it be?
3.
Yeah, it would be 3. And the failures?
7.
7. Excellent. And so just in case, if you need help, when you see this 3 to 10, 3 over 10, this is success to total, right? And then odds in favor is success to failures. And then odds against is just failures to successes, which would be 7 to 3. Notice that 3 plus 7 equals 10 because failures plus successes must be our total. Yeah? Everybody okay with that? Any questions on that? All right. You try this one. We're going to put our answer in the chat. I want you to find odds in favor first. So just odds in favor. So you're given the probability that the event happens is 19 to 40. What are the odds in favor of that event happening? So I'll give you, don't hit enter yet on your chat. I'll give you about, I don't know, 10, 20 seconds for that. All right, let's put it in the chat. 3, 2, 1, go. You guys are so excited to put it in the chat. I didn't even have to say go. Okay, I'm seeing lots of different answers, right? Some are the same. Some are different. I seem to see a lot of 19 to 21. So can someone explain to me why it might be 19 to 21, why they got 19 to 21?
I can explain it.
Good, McKenna.
So we know that the probability of an event happening is 19 over 40. So right there, we know that there is going to be a 19 for the odds in favor. And then if we subtract 19 from 40, we know that there's going to be 21 that would be against. So the ratio would be 19 to 21 for odds in favor. And then we would just flip it essentially for odds against.
Very nice explanation. So those of you that didn't get 19 to 21, do you see how I'm labeling some things here? I think this is a very helpful strategy. So when you originally get your probability of 19 over 40, the numerator is the number of successes. The denominator is the total possible outcome. Then when McKenna explained that she took 40, which was the total, minus 19 that were the successes, then you must end up with the failures. That's 21. So, and if you remember that odds in favor is success to failure, then you just have to plug in what you just figured out. And like McKenna said, when you do odds against, you just reverse those, because it's failures to successes. Now, do you notice that 21 plus 19 equals 40? It's not a coincidence, right? It's how they're calculated. So does that help? Any questions on that, what we just did? Okay, before we talk about the dice activity, I'm gonna put a document in the chat, and you could just write it on paper. You don't have to use it, but if you wanna put it in your notebook or whatever, you can. And I put it here in my notebook, right here. So is everybody okay? Are you done taking notes on this part for a sec? Okay, because I just want to show you. So this is the document I just put in the chat. What I want you to do, this is a great way to review. First of all, do you understand probability, but also can you compute odds in favor and odds against? I won't do the first one because I think the first one is too easy. So do you want to pick one? Do you want me to do the dice, the first one, the second one, or do you want me to do the cards, the first one or the second one? I'll do it as an example. Which one? Cards, McKenna? The drawing an ace or drawing a club, or do you care? Doesn't matter. Okay. Vanessa, do you have an opinion, drawing an ace or drawing a club?
It doesn't matter.
Okay, perfect. I'll just do the first one. Okay, so I'll just do drawing an ace. So the probability of drawing an ace is going to be, there are 4 aces in the deck out of 52 total. Do you agree with that? Some of you might need to refer to a deck of cards to make sure, right? Because we're not all familiar with cards. I can simplify that probability, right? And I can simplify it to 1 over 13. Now, if you label these things, it might help you make sense of the odds in favor and the odds against. So this is success, and this is total. I'm going to use the original numbers because I think it's easier for us to understand where we're getting the numbers in the ratio instead of using the simplified answer. Okay, so over here, when I say the odds in favor of drawing an ace, you could even write at the top of your paper that odds in favor is equal to success to failures, and odds against is equal to failures to successes. The more times you write these down, the less likely you are to forget them. So total equals successes plus failure. So given these 3, you should be able to figure out any of these problems or any odds problem. So I'm doing odds in favor of drawing an ace. So I want success to failures. Well, I know there's 4 aces in the deck, right? Those would be my successes. How many not aces are in the deck? Well, that would be 48. Do you agree that 4 plus 48 is 52? So that's how I knew there must be 4 aces in the deck, and there must be 48 not aces in the deck. And I could simplify that to 1 to 12. Do you see how it would be 1 to 12 instead of 1 out of 13 like the probability is? See the difference between those? The nice thing about odds against is you just reverse them. I don't know why I don't have very much room right here, but 48 to 4 is the same as 12 to 1. So does that help you? Excellent. I'm going to put you in breakout rooms to finish this chart. Okay, call me in if you need help finishing your chart. I'll make our rooms a little bit bigger this time. Like with 4 in a room, because I think it'll be a little bit faster for you. All right. Go for it. When you're done, you can just come back out to the main room. You don't have to wait for me. Okay. Okay. So we'll debrief that activity for just a second. Then I want to talk to you about your dice activity that you have that's due by Friday. And I thought I put it in the chat, but I know it's the wrong one that I put in the chat. So hold on. I don't know it's the wrong one, but yes, it is the wrong one. So here's the right one. I've rewritten this activity a few too many times. Let me just say, because I had to rewrite it for technology issues as well. Okay, so quickly, I'm just going to pick on a group. I will say the group Elena, Bethel, Jessica, and Karina, who were done first. You can pick any one of these to explain. So tell me which one you want to do.
I could just do the second one, the dice.
Perfect.
So the probability of rolling a dice would be 1 out of 6. The odds in favor of rolling a 6 would be 1 out of 5. And the odds against it will be 5 out of 1.
Do you guys all agree? Excellent. And am I still sharing my screen? Please tell me yes. Oh, thank goodness. Okay, good. Now, how about Alyssa, Andrea, Brianna, and Tyler? Which one do you want to do?
I can do drawing a club.
Okay.
So the probability of drawing a club would be 13 out of 52. Or if you really wanted to simplify it, 1 in 4. Odds in favor of drawing a club would be 13 to 39 or 1 to 3. And then odds against drawing a club would be 39 to 13 or 3 to 1.
Everybody agree with that one? Questions, concerns, problems? All right. McKenna, Sunita, Sydney, and Vanessa, which one do you want to do?
We can do rolling an even.
Okay.
So the probability of rolling an even is 3/6, so 3/6. And then simplify that down is to 1/2. Odds in favor of rolling an even is 3/3. And then rolling against is also 3/3.
Can you simplify that 3 to 3 at all? To what?
Could it be 1 to 1?
It could be 1 to 1.
Sorry, I was muted.
Very nice. Good job. 1 to 1. Excellent. Now, that's when you have to be careful if you're teaching this to students, because let's say they write it as a fraction and they write 3/3. Sometimes they'll just go like this and say that equals 1. Do you see why that's problematic when we're talking about odds? Because now we just have a whole number. We no longer have that ratio of success to failures or failures to successes. So you really have to talk them through why it may be important. And when I taught it in middle school, I made them write any odds with a colon, just to make sure they understood. So then that simplifying problem would not happen. Okay, so I just required all odds to be written as a colon. Okay. Okay, last one, Betty, Hannah, Kelsey. Can you do the coins for us?
Yeah, I can do it.
Okay.
Well, the probability of getting heads would be 1/2.
Okay.
And then the odds in favor of heads would be 1 to 1.
Very good. And then odds against, I don't know why it
Would
doesn't
be
say that.
1 to 1 as well.
Very nice. So what do you think this means with probability when we end up with this 1-to-1, because it happened when we had our probability of heads, and it also happened when we had rolling an even number. What do you think that means? Think of our vocabulary words that we learned. Is it an impossible event? Is it a certain event? What are these events? 50-50 chance, love it. So these are equally likely. Do you agree? And there's only two options. They're all equally likely. The for and against. Very nice. Okay. Now, for your homework assignment, I just want to make sure you understand the activity, because sometimes that's half the battle, right? Is understanding what it's asking you to do. So I'm going to put this page right here in our notebook. Okay, it's your home dice activity, which hopefully it will update. There we go. Okay, so it says rolling a six-sided die. When rolling a six-sided die, the theoretical probability of rolling a 1 is, what would you put in that blank? Anyone?
1/6.
There you go, 1/6. And then how do you know? You can write that later. Then I say, okay, we're going to use a virtual simulator to do some things. And I never got to show you your simulator on your calculators. I should probably just make a video of that because it seems to be problematic for me. Okay, so I'm going to put this simulator in the chat because it's easier for me to grab it out of the chat right here. Oops. So GeoGebra is something we will be using when we get to geometry, but you can also see that it's used for a lot of different things. So here's 2 dice, and we could roll them, and it'll tell you what happens. Oh, I thought, let's just auto roll. And we can stop it whenever we want. And it's preparing this frequency table for us so we can see what happens, which is really cool. Okay, because you might be a predictor of some things. This is a very interesting simulator, what's happening experimentally, because it's a little unexpected. There we go, now it's coming. The more I do, the better it gets to what the empirical probability is. So, but that's just a nice way you can see it happening, and it's giving you all of that. What's cool is you could change the number of dice. You can go to 1 dice or 2 dice or 3 dice. So this is kind of a fun one. This is written in GeoGebra, which is a free software as well. So it says roll the dice 36 times using the virtual simulation and record your data in the table provided. Now, this is just using 1 dice. So make sure you set it to 1 dice, yes, before you do it. So make sure you do that. And then you're recording, and then it says, how often should have the number 1 come up? And that goes back to what you predicted on number 1. And then you're going to explain it, okay? And then it says, if you were to reset the simulation, would your results be the same from the first simulation? Explain in detail. That you should use probability vocabulary. If you're not sure if they will come out the same, do it again and see if it does. Yes? Okay. Then when you roll 2 dice, it's going to ask you some other questions. And now it wants you to simulate rolling 2 dice and 36 times. So on this page, we're doing 2 dice and we're doing it 36 times, and you're going to record it right there. You're going to answer these questions. Then this is the part that people get confused by. So that's why I wanted to go over it. On number 6, what I want you to do is, this is a sum of 2. This is a sum of 3. This is a sum of 4. Does everybody understand what's happening here? Okay, so some people like totaled the column. Don't do that, right? Total each one. And then you should be able to answer that. Now, This is the table that's going to take you the most time. Do you see how that's in blue, odds in favor and odds against? Just in case you forgot what that means, that links you to an explanation of odds in favor and odds against. And then I did one of them for you. I did the number 7 for you. So there's 6 ways to make a 7 using 2 dice. And so you write 6/36, which simplifies to 1/6. And then just like we just did with our other paper, I converted that to odds in favor and odds against. So that's what you'll want to do on each one of these lines. Does that make sense? Okay. And then you're going to finish the activity. Make sure you practice. When it says explain something or what's the difference or how do you account, this is when you're practicing for the oral midterm. Using your correct vocabulary, this is where you're being really careful about how you write things. Okay? Make sense? Questions, concerns?
Your office hours are at 6:30?
No,
Or
7:30.
7:30. Oh, okay. Thank you.
Yep, no worries.
On number 8, the columns, there's 2 that says odds in favor of some occurring. Is the second one on the right side against?
Oh, this is supposed to say against.
Okay.
I can change that doc too, I think. Let me go and change it right now. I'm sure it just copied that, you know, it auto-corrected that cell. That's annoying. And nobody told me before, Sunita, so I'm so thankful you told me. Okay, I'm gonna put this in the chat, your exit ticket in the chat. All right, and then I'm gonna show you this last slide so you know where we are. So there you go. So tonight, you have the last banana video assignment, the independent versus dependent video assignment, and your first post on your live or die discussion board, which I hope you like. I think it's super fun. Make sure you don't just show me one possibility. It says you want the highest chance. So you better prove to me that it's the highest chance, right? If you just say this is the only chance, well, hello, how do I know? Okay, and then Friday, we just went over the dice activity. We've talked about the rock, paper, scissors activity. Tomorrow, we'll talk about the kids' meal simulation. And then you definitely have your probability homework and more, and your quiz. And then did you guys look at your team probability investigation yet? Did you see who's on your team yet? Okay, we'll talk about it in class tomorrow. So make sure you do your exit ticket. And then I will see you tomorrow. Stick around if you have a question. Betty, I want to ask you a question. Okay.
Okay. Did you want to ask me right now or when everybody leaves?
Hold on one second. I'm just
Okay.
getting to my spreadsheet of my exit ticket so I can see how everyone's doing. Okay, so Betty, you said, can you make a video? What video are you asking for?
Because you were talking about the calculator right now, and I wasn't sure if you wanted us to use the calculator.
Oh,
so you
yeah,
could use...
no, you don't have to. But
Okay.
I will make a calculator. I will make a calculator video of how the calculator can do dice for you and coins for you.
Okay. Yeah, that's what I was talking about.
Okay.
All right. Thank you.
Good. Yep, no worries. Everybody's so quiet today in this class. I got to change that. I got to make you guys do more talking.